Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So as for today, we are going to proceed with the design of our pre-stressed concrete structure, and we are going to touch on the pre-stress loss, right? So if you still remember in our previous topics or previous lessons, we have already determined the values of the pre-stress forces, and also we have compare our value of the pre-stress forces with the limiting stresses, right? So as you can see in the equations, when we talk about the value of the pre-stress force or the pre-stress with regards to the service condition, right? So we can see that we are referring to this pre-stress loss, right? So we have already learned how to use the factor which is included inside the equation, right? Which is the K value, right? So what we are going to learn today is the types of pre-stress loss that we are considering in the pre-stress concrete design, right? So first we look into our lesson outcomes, right? So at the end of this lesson, you should be able to understand and distinguish the types of pre-stress losses that occurs in the pre-stress concrete structure. And the second one is to be able to determine the percentage of the pre-stress losses, right? So we are going to go through a few examples on these losses. Okay, so for the pre-stress losses, it can be categorized into two, which are the immediate losses, and also the time-dependent losses, right? So, what is immediate losses, right? So, for immediate losses, it depends on the method and equipment used to pre-stress the concrete, right? So, for immediate losses, usually this is considering the transfer stage, whereas we are transferring the pre-stress force to our concrete, right? So as for this, so these are the few immediate losses that we are considering in our calculation, which are the elastic shortening of concrete, right? Then we also have encouraged losses, right? So for encouraged losses, this is usually considered for post-tension members, right? Then we have friction in the jack and along the tendon, right? Then we have steel relaxation and also deformation of forms for precast members or in the joints, right? So you can see here for immediate losses, it will actually be depending on the method and equipment used, right? So whether it is a pre-tension member, or it is a post-tension member, right? Then we have another one, which is the time-dependent losses, right? So this will consider the gradual losses of pre-stress that occur with time over the life of the structure, right? So it does not happen immediately, right, after the pre-stress force has been subjected to our structure, but it is the losses that occur over time, right? So it takes a long time during service of our structure, then it will actually be subjected to this type of losses, right? Then we also have gradual shortening of the concrete, that is due to creep and shrinkage, right? So as what we have known, right? So creep and shrinkage are long-term deformation, right? So it occurs over time, right? So therefore, this has to be considered in our pre-stress loss. Okay. Then we also have relaxation of tendons after transfer, right? So this is actually quite different, in comparison to the immediate losses. So here also we have this relaxation, right? Then we also have time dependent deformation within the joints in segmental construction. Right? So these are the two types of pre-stress losses that we are going to look into. Right. So here is the basis of pre-stress losses in general, right? So these losses will occur for any forms of construction used, right? So it can be for pre-tensioning method, or if we are using the post-tensioning method, right? So either one of these construction methods will also give the some values of losses, right? So losses in pre-tension structure is usually higher. So why is it higher? It is due to the immature concrete at transfer, right? So if you still remember when we learn on the pre-tensioning method, right? So we know that we are going to provide the tendons, okay? Then we are going to stretch the or apply tension to the tendons first, okay? Then only we will pour the concrete, right? Okay, so here, okay, we are when the tendons are cut, right? Okay, so therefore that is where the pre-stress force is transferred to the concrete, right? So during that time, okay, usually we are going to consider, okay, that we have the immature concrete with lower strength, right? So that is why, okay, we can see that we have higher losses in pre-tension structures, okay. And as for post-tension structure, okay, so because stressing in post-tension structure is sequential procedure, okay, which is not instantaneous as pre-tensioning, right? So pre-tensioning, okay, we are considering the losses at the higher losses at transfer, okay, but as for post-tension structure, okay, since the concrete has hardened first, okay, then only we apply the stresses, okay. Therefore, as for this, okay, the losses will be much lower, right? So prestress loss at transfer, okay, is usually approximately 20 to 30%, right? So further losses occurring in post-tension concrete, okay, during the stressing procedure, okay, is due to friction between the strands and the ducts, especially in curved profiles, right? So this is for post-tension concrete structure. Right, then the second one, okay, it is due to the mechanical encouraged slip, right, during the stressing operation, right? So when you talk about a post-tension concrete structure, right, so therefore we are going to have this encouraged, right? Okay, which is considered as the lock, right, for our tendons, right? Then it also depends on the actual system of ducts, okay, encourages, and also the stressing equipments used, right? So this is for post-tension concrete, right? So we can see here in general that both types of methods, okay, will also contribute to these pre-stress losses. Okay, so this is the clause, okay, that is given by the Eurocode, okay, with regards to the immediate losses, right? So immediate losses of pre-stress for pre-tensioning, okay, whereas we have the following losses occurring during pre-tensioning should be considered. So one is during the stressing process, okay, where we have loss due to friction at bends, okay, in the case of curved wires or strands, and losses due to wedge draw-in of the encouraged devices, right? So then before the transfer of pre-stress to concrete, okay, loss due to relaxation of the pre-tensioning tendons, okay, during the period which elapses between the tensioning of the tendons and pre-stressing of the concrete, right? So, and the third one is at transfer of pre-stress to concrete, okay, which is the loss due to elastic deformation of concrete as a result of the action of pre-tension tendons when they are released from the anchorages, right? So this is where what I have mentioned just now, right? So these are the losses, okay, or immediate losses that has to be considered, okay, if we are using the pre-tensioning method. Right, so first, okay, we go through the losses that is due to the elastic shortening, right? So when we talk about elastic shortening, okay, therefore we are actually considering the losses that happen in the concrete, right? So we can see here, okay, in pre-tension concrete, okay, these losses due to elastic shortening occur immediately after transfer, right? So when our structure, okay, is subjected to compression, right? So with regards to the pre-tension method, right, so we know that once the concrete hardened, right, then the tendons will be cut, right? So that is when, okay, we have the pre-stress forces, okay, transferred to the element, right? So the steel will generally shorten, okay, by the similar amount with corresponding loss of pre-stress, right? So this is for the pre-tension concrete. right? Then in post-tension concrete, right? So we have two cases here. Okay, one is when the tendons is stressed simultaneously. Okay, whereas if we have one or more tendons, okay, so all tendons are stressed together, right? Okay, so therefore, as for this case, right? Okay, we are going to have elastic deformation that occurs during the stressing operation before the tendons are anchored, right? Okay, and for this case, the elastic shortening losses is equal to 0, right? So we assume that we do not have any losses here, okay, if the tendons are stressed simultaneously, right? And as for the second one, okay, when we have tendons that is stressed sequentially, right? So sequentially means that the tendons are stressed separately, right? So we have the sequence, okay, for each and every tendons, right? So earlier stress tendons suffers the largest elastic shortening loss, right? So the first one, okay, the first stress tendons, okay, will suffer the highest shortening loss, right? And it can be reduced, okay, by restressing the tendons. And as for the last tendon stress, okay, it suffers no elastic shortening, right? Okay, so we can see here, okay, the first one will suffer the highest shortening loss, okay, but as for the last tendon that is stressed, okay, it undergoes no elastic shortening, right? Okay, so if we have this tendons that is stressed in sequence, right? So what we can do to reduce the losses is by restressing the tendons, okay, right? So restressing is usually done, okay, before all the tendons are anchored, okay, to the sides of our structure. Okay, then tendons are not bonded to the concrete, okay, until grouting process. Okay, so it is the shortening of the member, okay, between the Anchorage plates, okay, that causes the elastic shortening, right? Okay, so this is the shortening, okay, that is between the anchorages. Okay, so that is for the first one. Okay, then the second one, okay, is the losses that is due to friction, right? So these losses due to friction is particularly for post-tension method, right? So the first one, okay, it is the losses due to friction, okay, in the jack and also anchorage, right? So these losses depends on the jack pressure, the type of jack that we are using, and also the anchorage system, right? So these losses is allowed during the stressing process, and relatively, okay, this value is very small. Right, then the second one, okay, is along the tendon. Okay, so in post-tension members, losses occur along the tendon during stressing, right? So friction between tendons and ducts causes gradual reduction in the pre-stress, right? Okay, so we know that when we talk about post-tension structure, okay, it means that we are going to apply the ducts, okay, and the tendons will go through the ducts, right? So we are going to consider, okay, the coefficient of friction, which depends on the condition of surface in contact, okay, the duct profile, and also the tendon nature, right? So we can see here, this is the clause, okay, that is given by the Eurocode, okay, with due to the losses due to friction, right? So we have this equation, okay, and we can see that we are considering this coefficient of friction, right? So this is the coefficient of friction between the tendon, okay, and also its duct, right? And we also consider the sum of angular displacements over a distance x, right? So this is actually considering the type of a tendon profile that we are using, right? So we can see here, right? So the value of the coefficient, okay, is given by table 5.1, right? So we can see here coefficients of friction, okay, of post-tension internal tendons and external unbonded tendons, right? Okay, so we have internal, okay, and also we have external unbonded tendons, okay, and you can see here it is divided into different types of tendons, right? Okay, so we have cold drawn wire, strand, deformed bar, and smooth round bar, right? Then we have the internal tendons coefficient, right? And also external unbonded tendons, right? So for external unbonded tendons, okay, so we can see that we have different conditions here, right? So we have steel duct, okay, which is non-lubricated. Okay, then we also have HDPE duct, okay, which is also non-lubricated. Okay, and also we have similar material, okay, of the ducts. Okay, but as for this case, okay, the surface is lubricated, right? So we can see here that there is a difference in the coefficient of friction, right? So if it is non-lubricated, means that the surface will be rougher, right? So therefore the friction coefficient will be much higher, right, in comparison to the lubricated surface. Okay, whereas okay, we have 0.18, okay, and also 0.1, right? So usually this lubrication involves greasing of the surface and so on, right? Then the third one, okay, is the Anchorage losses. Okay, so this is also for post tension method, right? So we can see that when post tension tendons are locked, right? Okay, so therefore it is bounded to these anchorage losses, right? So these losses happen, okay, due to slippage, okay, of the anchorage, and advice should be sought from the manufacturers of the anchorage system, right? So usually as for a post tension structure, okay, we are going to use different types of anchorages, right? So therefore there are a few guidelines or specifications that we need to know, okay, before we use those types of anchorages, right? So these losses, okay, when we talk about anchorages, it means that it is due to the slippage of the anchorage. Alright, then the next one, okay, is the other causes of immediate losses, right? So we have deformation of the forms, okay, so this is for precast members, okay, then so this forms, okay, is the formwork, okay, of our structure, right? So if we have any deformation on that, okay, therefore this will cause immediate losses to our structure. Then we have deformation of construction joints, okay, which is between precast units in segmental construction, right? So for example, if we are considering a bridge segment, right, okay, so we are actually uh, having a continuous segments, okay, that is arranged together, right? So therefore we are going to have this construction joints, right? So at this construction joints, okay, it is prone to this immediate losses. Okay, then we also have temperature changes, okay, that is during tendon stressing, okay, or the casting time in pre-tension members, right? So this can also lead to immediate losses. Okay, so now we move on to the next type of losses, okay, which is the time dependent losses. So when we talk about time dependent losses, okay, so we are going to refer to the time dependent deformation, right? So as for concrete, okay, it is prone to creep and also shrinkage, okay, and also as for the steel, it is subjected to steel relaxation, right? So this is the clause, okay, that is given by the Eurocode, right? So we have an equation, okay, a simplified equation that is given for time-dependent losses of pre-stress for pre and also post-tensioning. So the time-dependent losses may be calculated by considering the following two reductions of stresses, right? So we have due to the reduction of strain caused by the deformation of concrete due to creep and shrinkage under the permanent loads, right? So when we talk about creep and shrinkage, actually we are referring to sustained loadings, right? So sustained loadings means that we have our structure that is under load for a long period of time, right? So therefore, okay, it is subjected to this creep and also shrinkage. So then the second one is the reduction of stress in the steel due to the relaxation under tension, right? So the relaxation of steel depends on the concrete deformation due to creep and shrinkage. So this interaction can generally and approximately be taken into account by a reduction factor of 0.8. Right, so we are given this equation 5.46, right, which is a simplified method, okay, to evaluate the time dependent losses at location X under the permanent loads is given by this expression, right? So we can see here, okay, that in this equation, okay, it already combines, okay, the creep, shrinkage, and also the steel relaxation, right? So everything is combined in one equation, right? Okay, so we have the values, okay, that has to be substituted into this equation, okay, inclusive of the modulus of elasticity and also the area, right? Okay, so for creep of concrete, it is due to sustained compressive stress in the concrete, right? It could cause a long-term shortening of the concrete, okay, which could reduce the pre-stress force, right? Okay, so when we talk about creep in concrete, right? So therefore, it will be undergoing, okay, long-term shortening, right? Okay, and sometimes, okay, this will cause our concrete structure to crack, right? So factors affecting creep and shrinkage of concrete, okay, are the age of concrete, the concrete density, cement content, okay, water cement ratio, relative humidity, and also the temperature of our structure. Okay, so these are the equations, okay, that we are considering when we talk about the loss of pre-stress force, okay, with regards to the creep strain, right? Okay, so we have the stress in concrete at the level of the steel, right? So we have this equation, okay, and we can calculate the loss of steel stress, okay, whereas we have ES times with sigma CP, okay, multiply with a specific creep strain, right? Then therefore from here, okay, we can calculate the loss of pre-stress, force, okay, which is equals to this equation multiply with the specific creep strain. Right, so the value of this specific creep strain are influenced by several factors obtained by using creep coefficient. Right, okay, so we can calculate this value of this specific creep strain, okay, using this equation. Okay, whereas we are going to use this creep coefficient, okay, as well as the value of the modulus of elasticity for our structure, right? So this ECM value can actually be determined based on table 3.1, okay, from the Eurocode 2, right? So this actually depends on the value of our concrete strength, okay, the FCK value, right? So we can see here that after we calculate this, okay, then we are going to substitute this equation into this loss of pre-stress equation. Right, so let us look into one example. Okay, so we have this example one that is for creep loss. Right, so we have a post tension concrete beam of a rectangular section, okay, with the size of 100 millimeters wide and 300 millimeters deep. It is stressed by a parabolic cable with zero eccentricity at the supports and an eccentricity of 50 millimeters at the center of the span. The area of the cable is 200 millimeter square, and final stress in the cable is 1200 Newton per millimeter square. Right, so we are given the information in view of the pre-stressing cable. So if the ultimate creep strain is 30 times with 10 to the power of negative 6 millimeters per Newton per millimeter square of stress, and the modulus of elasticity of steel is 210 kilonewton per millimeter square, compute the loss of stress in steel only due to the creep of concrete. Right, okay, so we are given the information on our concrete section, okay, as well as the information on the pre-stressing cable. Right, so we are also given the ultimate creep strain, okay, and also the modulus of elasticity of the steel. Right, so this is how we are going to calculate. Right, so we have A, which is the area of our concrete. Okay, then we are going to calculate the remaining pre-stress force. Okay, so here we are going to consider the area of cable, okay, and also we are going to multiply this with the stress in the cable. So these two informations has already been given in the question, right? So just calculate this value, okay, which is P prime. So we have here 240 kilo Newton, right? So next, okay, we are going to calculate this I value, okay, which is the moment of inertia, okay, or second moment of area, right? So since the section that we are considering is a rectangular section, so therefore we are using this equation of BH cubed over 12. Right, so we have here Ki is equals to 225 times with 10 to the power of 6 millimeter to the power of 4. Right, so the stress in concrete at level of tendon, right? So at support section, right? So we are considering the end supports, okay, and also at midspan, right? So at the support section, okay, we have the eccentricity of equals to 0, right? So we are going to substitute this into this equation, right? So when we have this value E here is equals to 0, right? So therefore we are left with only this one value, okay, in this bracket. Right, so P prime over A is equals to 240 K times with 10 to the power of 3 K, then divided by the area of concrete, which is 100 times with 300. Right, so we end up with sigma Cp, okay, which is stress, the creep stress, okay, which is equals to 8 Newton per millimeter square. Right, so next we move on to the similar calculation, okay, but now we are considering the location which is at midspan, okay, whereas we have the eccentricity of 50 mm, right? So again we are going to calculate for sigma Cp, right? So since we already have this E value, so therefore we have this value of 10.7 Newton per millimeter square. Right, so based on those two values, okay, we are going to calculate the average stress, right? So the average stress that we have here is 9.3 Newton per millimeter square. Right, so next we are going to calculate the loss of stress in the cable due to the creep of concrete, right? Okay, whereas we are going to use this equation and multiply with the specific creep strain. Right, so this specific creep strain has already been given in the question, right? So we have ES, okay, which is the modulus of elasticity for steel, multiply with sigma Cp, then multiply with the specific creep strain given in the question. Right, so we have here 58.59 Newton per millimeter square. Right, so in the question, what we are required to do is actually to determine the percentage of loss, okay, that is due to creep. Right, okay, so we know that the loss here, okay, the value of the losses, okay, is 58.59, right? So therefore to calculate the percentage of loss, okay, we divide this by 1200, okay, which is the final stress in the cable, okay, just now given in the question is 1200, right? Okay, then multiply this with 100, right? So we can see that the percentage of loss, okay, is 4.9%, right? So if you still remember when we talk about the calculation, okay, which considers the pre-stressing force, right? When we are considering the value of K, right? Okay, whereas we consider the pre-stress loss, we are referring to the percentage of losses, right? So as you can see here, this is one example, okay, of the calculation of a loss percentage, right? So and this is due to the creep. Right, so next is steel relaxation. Right, so steel relaxation, okay, is the relaxation of wire and strand under sustained tension, okay, which is a significant factor. So precise value, okay, will depend on the construction method, okay, and the steel type. So the relaxation amount will depend on initial tendon load relative to its breaking load. So in most practical situations, the transfer steel stress is about 70% of the characteristic strength, with the relaxation losses, which is approximately 4 to 10% of the tendon load remaining after the transfer. Right, so this is another type of time dependent losses. Okay, all right, so we look into one example, okay, that is using the time dependent, that is using the equation, okay, or the simplified equation that is given in the Eurocode 2, right? So this is the equation, okay, that combines the still relaxation, okay, as well as for the creep and also shrinkage, right? So we have one equation, okay, that will cover all the types of time dependent losses, right? So we have one example here, okay, which is a rectangular section, right, with the total height of 800 millimeters, okay, with the width of 300, right? So and all the values, okay, that is required in the question, okay, including all the coefficients, okay, are given in this question, right? So you can see that we have the modulus of elasticity, okay, and also we have the coefficients, okay, is already given in the question, right? So the material properties are as shown in the figure, and the pre-stressing force in the tendon immediately after transfer, okay, when immediate losses had taken place and before the duct was dropped, okay, is PM naught equals to 1350 kilonewton, right? So this is the initial loss, okay, which is immediately after transfer, right? Okay, so the sustained external bending moment M external is equals to 270 kilonewton meter, right? So this is the moment, right? So you can see here that the moment has been stated here, right? And the area of the steel reinforcement, okay, as well as this tendons has already been stated here as well, right? Okay, so what we are going to do is that we are going to just simply substitute, okay, all the values that has already been given, right? Okay, so we have these values of the coefficients, okay, as well as the values of the area, okay, and also I, right? So we are going to substitute everything, okay, into this equation, and we are going to get negative 225 MPa, right? Okay, so this is the value of the percent of the losses, right? Okay, so that is due to creep, shrinkage, and also the relaxation of steel, right? So in combination of this, okay, therefore we can calculate the percentage of losses, okay, that is due to the time dependent factors, right, which is equals to 225, right, which has already been calculated just now, divided by 1350 times with 100, right? So we can see here, okay, that the percentage of losses due to time dependent deformations is equals to 16.7, right? So this is one simplified equation, right? So actually we can do the calculation for this time dependent losses, okay, that can be done separately, okay, whereas we can consider creep, then we consider shrinkage, and then we consider relaxation of steel, then we add up all these three, right? Okay, so but however, okay, in the Eurocode, okay, we have already been given, okay, this value, this equation, okay, which is a simpler equation that we can include everything into one formula. Okay, right? So I think that would be all, okay, for the pre-stress loss, right? So these are actually the basis, okay, on how the pre-stress loss percentage is obtained, right? So later, okay, we are going to learn, okay, how to calculate this, okay, as well as we are going to substitute, okay, the values of the pre-stress loss in our calculation. Okay, so with that, thank you very much. Assalamualaikum.